All right, today's lesson is solving exponential equations. The first type of exponential equations we're going to solve are ones where you can change one side of, basically so you can change it so that both sides have the same base. Right now, it's 2 to the 3x minus 8 equals 16, but we can change 16 to a power of 2 because 16 is 2 to the 4th. And then since they have the same base, we can just set the exponents equal to each other and solve. So we add 8, we get 3x equals 12, and x equals 4. This next example, we're going to do the same thing, except it's not as easy to tell what the base should be, because 8 is not a power of 4, and 4 is not a power of 8. But they both are powers of 2. 8 is 2 squared. And then, 8 is 2 to the 3rd, my fault. And 4 is 2 squared. Then we just set them equal to each other, the exponents. We get 3x plus 6 equals 2x minus 6. We solve for x. And we get x equals negative 12. So those are the easier types of exponential equations. The harder ones are where you cannot make them the same base. So what you need to do is first isolate the exponential expression. Well, here it's isolated. You have 4 to the x equals 15. You have the exponent and the base on one side and all the other stuff's on the other. Then the second step is to take the natural logarithm of both sides. If the base was 10, then you would take the log of both sides, because remember, log is base 10 and they would cancel out. But for this, you take the ln of both sides. So you go ln for the x equals ln 15. Now remember, the properties of logarithms allow you to roll exponents to the front. And this is how you're going to get the x out of the exponent to solve for it. So you have x ln 4 equals ln 15. And then you can solve for the variable by dividing by ln of 4. So you get x equals, and the ln of 15 divided by the ln of 4, using your calculator, will give you 1.95. So let's do the next one. Same situation, you have 5dx equals 134, so you're going to take the ln of both sides. The x is going to roll to the front. And then you're going to divide by the ln of 5. So that x equals the ln of 134 divided by the ln of 5. And it's 3.04. The next one is an example where you would have to isolate first, because notice you have 5 on this side, so you got to get the 5 over there. So you get 7 e to the 2x equals 63. You also have to divide by 7, so that it's just e to the 2x equals 9. So notice the base and the exponent are isolated. Now you take the ln of both sides, and remember, the hidden base of e, or ln, is e. So notice if the base and the number are the same, they'll cancel out, and you're just left with 2x equals ln 9. So then you're just going to divide by 2. And you get x equals the ln of 9 divided by 2, which is 1.098, which rounds to if I round to nearest tenth, 1.10 approximately. The next one is a little more complicated because there's exponents on both sides. So you can't isolate the exponential expression on one side. So basically you're going to have to leave one on one side, one on the other. But you can take the ln of both sides here. Now remember, the exponents roll to the front. So you have 2x minus 1 times the ln of 3 equals x plus 1 times the ln of 7. And you might be like, well, how am I going to isolate the x when there's an x on both sides? Well, you can't at this point. So let's do what we can do, and that is, since we have parentheses, we can distribute in the ln of 3. So we have 2x ln of 3 minus ln 3 equals, distribute the ln of 7, so x times the ln of 7 plus ln 7. Now remember, our goal is to get x by itself. So let's move all the things with x's, like for example, this has an x, so I'm going to move it to the other side. So I'm going to subtract. So I get 2x ln 3 minus x ln 7. And then I'm going to take this term here that doesn't have an x, and I'm going to move it to the other side by adding the ln of 3. Now keep in mind, these are not like terms. The ln of 7 plus the ln of 3 is not the ln of 10. Alright, so we have to keep them separated. So ln 7 plus ln 3. Now at least we have x's on one side and everything else on the other. So now, notice there's an x here and an x there. So what we're going to do is factor out that x. And then, to get the x by itself, we can divide. And notice, now we have x equals this, and we can type it in our calculator. Now this would be an exact answer. So in your book, for the problems, it's going to ask you for an exact answer. So this would be your exact answer, all this good stuff here. That's your exact answer. But it's also going to ask you for a decimal answer. So you do need to type in your calculator, and you would have to put parentheses. So if I was typing it in my calculator, I would want to type it in basically like this, divided by parentheses 2 ln 3 minus ln 7, like that, in your calculator. When you do that, as I'm doing it right now, you get 12.11. So it's approximately 12.11. All right, so the last example is one where you're going to have to factor, because notice you have a trinomial here. And you actually have a quadratic, because notice it's e squared, or e to the 2x, and then x. So basically what we'll do here is a diamond. We'll say, what are the factors of 7 that add to -8? And they are -7 and -1. So we'll have e to the x and e to the x, and then we'll have -7 and -1. Now we'll solve each parenthesis. So e to the x minus 7 equals 0. E to the x minus 1 equals 0. remember, you want to take the ln of both sides after you add 7 here, and after you add 1 here. To get the x down, you're going to take the ln of both sides, and remember, when you take the ln when there's an e as a base, it cancels these out, so you're just left with x equals ln 7 and x equals ln 1. Those are your exact answers. To get the decimal ones, you type it in your calculator. Ln of 7 is approximately 1.95, and ln 1 is 0. Because remember, anything to the 0 power is 1. So those would be your decimal answers. These would be your exact answers as ln 7 and ln 1. Hope this helps. Any questions, please feel free to email me or ask in the beginning of class. Don't forget, the links are now on our agenda. So the link to the questions is on our agenda. So please check that out. And also, have a good 3-day weekend, and see you all on Tuesday.